In this video, I will explain how to write an assembly language program to perform the string operation. So here in this program, there are three string operations and that are explained in detail in the three videos, and the link for the videos I have pasted in the description box. So the first part of our code is we have to accept the string. So this code is written to accept the string from keyboard. The second part of our code is we have to display the length of the string, and that is explained in the second video. And the last part is we have to display the string that is entered from the keyboard. So this part is explained in the third video. You can check the links in the description box. And now in this video, I will explain how this program will be executed in our emulator screen. So now let's redirect to the emulator screen. So this is the program for our enter the string, length, display length of the string, and display the string whatever you have entered from the keyboard. So in this program, there are multiple parts. That is, first of all, we have declared here the data segment, the data variable that is required in our program. In that code segment, we are writing here this micro for displaying this message 1, message 2, and message 3. Whenever you have to call this micro, that time we are calling with the help of name of the micro, that is disp, and the parameter that we are passing, that is m1, m2, and m3. So whenever I am calling this micro, then whatever the parameter that I am passing, that data will be printed on our console. So first of all, I'm passing here message 1. So whenever I'm passing this message 1, so message 1 consists of enter string. So whatever the string you have to enter, that can be entered with the help of 0AH interrupt. But before that, if suppose you have to print this message on the console, that is enter string, so this will be printed with the help of this micro, and within that micro we have written this code, that is this three group of line of code. And here we have to call the DOS interrupt, that is 09H interrupt, and we have to call this DOS interrupt and we have to copy the contents of 09H in our AH register. And with the help of load effective address, we are passing the argument, that is XX, in our DX register. Whenever we are calling this variable M1, then the values that are stored inside the M1, that is enter string, that is passed to the XX parameter. And here we are loading the value of our XX parameter into our DX register. So check here, the values of DX will be updated, and with the help of integer 21H, we are displaying the enter string on our console. Now we will move to the next part of our code, that is we have to take the input from the keyboard. So for taking the input, we are using this 0AH DOS interrupt. So whenever I am executing this code, the 0A value will be copied into our AH register. Now with the help of load effective address dx comma string 1, the string 1 address will be copied in our dx register. And with the help of integer 21H, it will prompt the user to enter the string and waiting for the input from the keyboard. So I am entering here ABCD and I am pressing on the enter button and I am leaving the control from the keyboard. So whenever I am leaving the control from the keyboard, I have to press on that single step mode of execution again. So I'm clicking here on the single step execution, then I'm redirect to the next part of our code. So now this part will be completed, that we have entered the string from keyboard. Now we have to display length of the string. So first of all, we have to display this message that is stored in our message 2. So the same technique will be applied, that is we have seen already for DISP M1, that is message 1. So whenever I am calling this DISP message 2, that time our microcode will be expanded here in that group of line of code. So here I'm clicking on that single step mode of execution. Then this code will be executed. This code will be executed. You can check here this content, that is move h, 09h and load effective address dx, xx and integer 21h. With the help of this three line, we are printing here length of the string. Now you can go to the next part of our code, that is here these are the actual content we are writing for printing the message, that is 04 on our console. So we have entered this ABCD on our console, and after entering the ABCD, our length of the string will be updated in that question mark part. Okay, so in the previous video, we have already seen the concept of string 1 plus 1, then string 1 plus 2. So that is string 1 of 0, string 1 of 1, and string 1 of 2. So here you can check that in that string variable, we have written 50 comma question mark, 50 DUP of question mark. So the first byte is 50. So it will allocate the maximum length of your string. So you can take the data from the keyboard till 50 characters. The second byte indicates that you can take the length of the string here, and the length of the string will be updated here once you are entering the string from the keyboard. And the third part of our code is whenever you are entering the string from the keyboard, then this data will be updated in the third byte of our code. The third byte of our string will be 50 DUP of question mark. So that means that your 50 duplicate memory locations will be allocated for your string 1 variable. So here there is a question mark, and now this will be updated with our value 04. Now you can check here. Whenever I'm clicking on that single step mode of operation, the string 1 plus 1, that value will be updated in our console. So check here what is the next part of our code. Here we are doing the step-by-step execution of our displaying the length of the string. So string 1 plus 1, whatever the contents are there that are loaded in our SI register. So now our SI will be 0000. So after updation, it will become 003A. So 003A is the starting location of our length of the string. So now whatever the contents are there in that 003A location, so the contents of the 003A will be the length of the string, that is 4, because we have entered ABCD on the console. So the value of 4 will be copied into our CL register, because we are writing here move CL comma in bracket SI. So now check that our CL will be updated and it will become 04. Now this value will be updated in our L1 register. So L1 is the variable, it is not a register. So L1 is the variable that we have declared in that program. So check here, this value will be updated in our L1 variable. You can check this variable value after clicking on that variable option. So check here, the values of variable will be updated and it will display on our console. So our console can only display the contents of the register. But if we have to see the contents of our variable, then this can be displayed with the help of this variable screen. So here the variable value will be updated and now it will become 04. So next line is we have to add this CL comma 38. So why there is need to add this CL comma 04 and CL comma 30? Because in that program, whenever we are calculating the length of the string, That time we have to check whatever the contents are there in our string. So now here we are adding add CL comma 30H. So our CL consists of value 04, and when we are adding here 30, then it will become 34. Now we have to print this 34 on our console, but 34 is the hexadecimal value of our code. So we have to take the hexadecimal value in our register, and then we have to print that value on our console. So our console can display 4, but our register consists of value 34. Now with the help of 02H DOS interrupt, we can print this 04 value on our console. But before that, whatever the value is there in our CL register, that we have to load into our DL register. So whenever we are calling this DOS interrupt 02H interrupt, that time they are taking the value from DL register. So now here we are copying the contents of CL into our DL register. So DL becomes 34. And with the help of this DOS interrupt, we are displaying the length of the string is equal to 4. Now the next part of our code is we have to display string on our console. So this code is written for displaying the string on our console. Thus first of all, we are calling the micro that is disp message 3, and the message 3 consists of argument that is display string, and that is written in our message 3. So whenever I am calling this display M3, that time the micro will be called and this code will be expanded in our program. So now we are displaying this display string with the help of this micro that is dispm3. And now you can check here the display string will be printed on our console. So now the next part of our code is load effective address si comma string 1 plus 2. So here we have written this string 1 db 50 comma question mark 50 dup of 0. So this part will indicate as string 1 of 2. So you can check here whenever I'm writing this instruction that is load effective address si comma string 1 plus 2, that time we are loading here the contents of si will be updated here and it will become 003b. So now we have to copy the length one that is L1 into our CL register. So our L1 variable will be 04 and that we are loading into our CL register. You can check here the contents of variable that is L1 is equal to 04H. Now you can click on that single step mode of our execution of our program. Then it will redirect to the next part of our code. And now the next part is move dl comma si. Here we have written this back one label for execution of this programming statement again and again till our ABCD will be printed on our console. So here what we have done, first of all, we have to copy the address of our SI location into our DL register. So our string consists of A, B, C, D. So they are taking the hexadecimal value of our A, B, C, D one by one into our DL register, and with the help of DOS interrupt that is 02H interrupt, we are printing one by one character on our console. Once we are printing one of the character from our console, then that time we have to increment the value of SI and we have to decrement the value of our CL. So how it will be updated, why we have to update, that we have explained in our previous video. So what is this change instruction, why there is need to create it, and why we have to call with the help of this back one label, that is also explained in our previous video. So you can check the contents of that previous video in our description box. So check here, what is the next statement, move dl comma si. So we are copying here the value of our SI into our DL register. So our DL will be hexadecimal value of our A, that is 61. And with the help of 02H interrupt, we are printing here A. Now we are incrementing this SI. So SI will be 003B and now it will become 3C. And we are decrementing the CL, that is CL becomes 03. Again, we are redirecting to the back one label and the DL comma SI. That SI will be updated and it will become 62. And again, we are loading here the contents and that we are copying the contents from register to console. Again, we are incrementing this SI and it will point to the variable that is C. And C will be printed and we are decrementing the CL and again we have to print the values of our next character. So check here with the help of integer 21H interrupt, we are printing the data from DL register to our console. Again, we have to increment the SI and now we are redirecting to the D variable. So that time it will become the value that is 64 and that contents are loaded in our DL register. And with the help of 02H toss interrupt, we are printing the data on our console. So now we have successfully printed this ABCD on our console. So what is the next line? Again, we have to increment the SI. Now it will pointing to the dollar string that is end of the string. Again, we have to decrement the CL. So our DL becomes now 00. So once it becomes 00, it will terminate our execution of this back one label because we have to check this JNZ instruction. And this instruction can executed. How it will be executed when our zero flag will be set to 1. So it will not redirect to the back one label. So our whole string will be printed on our console and it will be reached to the dollar string that is end of the string. So once all string will be printed and it will reach to the dollar string, that time our zero flag will be set to 1. And now we are not redirecting to the back one label again. It will jump to the exit label and with the help of dot exit statement, we are terminating our all data segment, all code segment and stack segment. And with the help of end, we are terminating our program. So now our program execution will be completed. So in this video, we have seen how to display, how to accept and how to display the length of the string in this string operation.